over 4B equal 7. Lower reaction 7.4B, correct? Start again. Start here, B. Start here, 0. And your shear force diagram is beautiful. Okay. Where is the zero shear point? Where is our zero shear point? This example is very nice for us. 81, 82. Okay. For sure, 100%. The moment this support is negative up, and for sure, 100% this negative positive moment down. Asking you about what maximum shear and stop. I have to tell you what maximum shear.
W is per unit length.
Here, W, if W equal B over L.
That is per unit length.
Yes.
This W is per unit length.
Yes, this is uniform load. Is if what I don't find the maximum vertical shear force if W equal B over L. He give you condition. Now, what is the maximum now shear force, internal shear force? Whatever, right hand side, left hand side, the section. Which, how many sections I have? I have 100, look at the section. 2, 3, 4, 5, 6, 7, 8. I will come here. This section now. You can now 3 over 4B, as I told you, and B over 4. Here, this section. Here is 3 over 4B, 3 over 4B. Here is B over 4, B over 4. 3 over 4B, here comes, stop, no, it's not all, it's not 7 over 4B, no. It's whatever, right or left. I tell you left, the section here like that, down is what? 3 over 4B, up is B. I will take a B. I will take a B. The answer is B. The answer is B. Means what? I calculate the maximum shear force. This B, I will take it in my design. I will not talk all the reaction. I will not tell the reaction is, why shall I calculate shear force diagram? Why we draw shear force diagram? To get the maximum shear force. Why we need maximum shear force? We need it in to calculate shear stresses. Why we need shear stresses? To check our designing concrete steel bars. One by one. Start structure analysis to steel design, to concrete design, to foundation, to the key. We have to understand now. You allow the moment diagram, how it will look like, I will draw it. I will erase this one, please, guys. Okay.
We are considering P maximum for
yes.
first condition.
Now the beam here, how many sections I have? Have every section. Take section here to go down. Take section here. Because this section have shear force. What is the value of shear force? Plus B over 4. Need to cut this section up. This is what I understand from the shear force diagram. Coming in this section. Section underneath B. Underneath B. The section here. We have reaction till you go up. And this down. You are now up. Now 4. B over 4 and down till me 3 over 4. You have right hand side, left hand side. See? You have the shear force here in this section, the maximum in this section. In this section is 3 over 4 B. In this section. The section have straight, yes, down, 3 over 4 B until I reach here in the support. Because there is support. The support telling me reaction. The reaction is not shear force. Reaction is not shear force. Reaction is reaction. Reaction is reaction. Shear force is different. Up and down. The beam up and down. Force up and down. You need to cut the section. Okay. In our structure analysis, our concern is a section. We design sections. Okay, remember, we are not concerned about support. We are not considered about external load. We consider our concern is the internal force. This is internal force. This is internal force. We take this internal force values, maximum of it to design. Okay, type. I will draw this, the bending moment diagram because it's very nice, very nice diagram. How to draw it? You have reaction here, and the reaction here, and support here, external force here, and you have equivalent moment at this section now. At this section, I am concerned right hand side. Right hand side is telling you what B multiply what 0.5 L. And our moment here is 0.5 L because this is L multiply LB. This is force LB. The moment increasing like that. Second curve, parabola curve, increasing with parabola curve. Very good. And here, the bottom here, it will be for sure like that. Let us see. Here, put your finger here in this section, down B. Reaction is 4 B 7 over 4 B, giving moment here positive. Why positive? Tension and lower Bible. 7 over 4 B multiply L. Correct? Right. Minus what? Minus LB. LB minus LB multiply 1.5 L. 1.5 L. You are now 7 over 4 BL minus 6 over 4 BL. صح كده؟ Correct. يبقى now equal 1 over 4 BL. يبقى BL over 4. BL over 4. يبقى now is BL over 4. يبقى now this is positive moment and this is negative moment. Where is right. What is the maximum moment here? Maximum moment 0.5 B. This is 0.25 BL over 2. And what is the maximum moment then? 0.5. I will take this value. This is very important value. I will take this value B here, B in our design. How? I will tell you now. I will send in our WhatsApp group a very important 2 questions repeated in our exam, and we'll discuss about it now to solve this quick answer and to finish the story. I will segregate now, guys. Next class, we are going to discuss project management, and I will give some question and structure analysis. Write it down by your own. You write it down by your own, and you are going to give me the answer, but you are going to solve it by your own. Okay? And this very important 2 questions, repeated, and confusing a lot of engineers. Follow me, please, online. Yeah, check. Right. Anyone here? I will erase this one. I will erase this one. We'll discuss about whatever we have. I will erase, guys. Okay. The answer is B. Now, yes, I will explain about this all this because this is the same structure analysis to close being part for A for good. If you have simply supported beam, uniformly loaded, means what? You have this beam is simply supported beam with uniform. Our shear force, it will look like that. If you have B, مثلا B feet, B bound over feet, assume whatever B, and you have L feet, assume. So here what? The reaction, it will be what? The reaction is B over 2. BL over A over BL over 2. And here is BL over 2. صح كده ولا لا؟ طب حلو. Your shear force diagram, it will look like that. For sure, 100%. I am telling you, for sure. Up, down, coming here. Why like that? This is zero shear point. Why? Because it will be like that. So now our shear force diagram will be positive, negative, zero shear point, zero shear point. What does it mean? And there is a section in neutral axis. There is zero shear in this section, but zero shear force is shear stress is zero. See, shear force, what? Yeah, this is neutral axis. Right. Moment diagram look like what? Come underneath zero maximum. Even down here is the maximum. Parabola curve is equal what? BL squared over 8. This is a formula. We are, all of us, if you calculate it, you will find it like that. Positive moment. Positive. All positive. But let us see. Where is the maximum shear? Force, shear internal force. Internal force. Where is the shear maximum shear internal force? Here in the supports. This is, we call here what? B L over 2. B L over 2. The maximum is here. Now, see. Any section here, any section, I will take section like that, assume. Section now, 1-1. This section 1-1, this is a section 1-1. Have any normal force? No. You are now normal stress is equal 0. Why? Stress equal force divided area. If normal force 0, that means there is no say normal stresses. Normal stress is always coming from this is the bend, this is the normal force, axial force, compression or tension. The stresses, normal stresses coming from tension, coming from compression. If number 1, we call it normal stresses. Different between normal force. When I say normal force, is not normal stresses. Okay? And it depends about the section, the area of the section,
Sorry, normal force. What's the difference between normal force and normal stress?
Normal force is a force, not force. Stress is force over area. Stress equal force over area. Normal force is force.
Yes.
Stress is always, when we call it stresses, we call it stresses force over area. Force over area. Normal stresses is 0. If a normal stress is 0. Okay, if a normal stresses is 0. Stress is 0 here. Right. Let us go for the same section. We need to calculate the shear stresses. Okay. Shear stresses in this section, it will go like that. Take our shape, this shape. This is the normal axis, and this is normal axis, and here is lower fiber and upper fiber. The normal forces is the shear force, shear stresses. It will be start from lower fiber with 0. Lower fiber stresses. Now I'm talking about stresses. It will be maximum on the neutral axis, and it will go again 0. Need to cut. But here is this is the shear stresses. If you have rectangular section, this is the shear stresses diagram. Equal what? Equal Q multiply LV over LB moment of inertia. We call it tau equal shear stresses. Shear stress equal what? Equal Q اللي هي shear multiply V. Sorry, Q اللي هي statical moment of the section multiply shear force V multiply الB اللي هي الB over the moment of inertia of the section. The moment of inertia equal الB H power 3 over 12 for rectangular section. And I equal. This is moment of inertia. Right. If you have a standard beam section, the standard beam section is like that. Your section is like that. Now, shear stresses diagram, it will be like beautiful shape like that. Start from 0. You must start from 0. This is in web. Pair all the stresses. See, in web, take all the flange taking little bit value of shear stresses, correct? From the figure itself, you found out that this is the neutral axis. Neutral axis. Now, start from 0, end of 0. Maximum in neutral axis. The shear stress in the section, maximum in neutral axis. Where is the maximum shear force here? In the support. You are for sure 100%. The section at the support have maximum shear stresses. Correct? Huh? Correct. Right. The same equation, go for here as well, and go for here. But we have a very beautiful equation as well, tell you what, average for standard I-beam. Standard I-beam section, we call it, what is average? Average is this area. Of the shear stress. Tell you what, telling you this is in shear stress V over the area of the web. Equal average, now average. Now I have two equations for the standard I-beam. This is equation maximum here until here, this is a maximum from this point to this point is equal Q, statical moment of the section, multiply V, maximum shear force divided by V.
We cannot see the formula at the below.
Second one, average. Tau average. What is tau average in the standard I-beam equal what? Equal shear forces. Equal shear force divided in area of the web. In exam, in our question, what I said now. Try to solve it, Keda. Try to solve it, Keda. If I will tell you now, if I give it to you everything now, I give you everything now. Let us solve it, Keda. Question number. I already.
Can you adjust the camera, sir, to cover the bottom of the board?
Wait.
Yes. Clear. Tay, shukran.
Yes. Right. Now, let us solve our question exam. Let us solve, guys. Question number, very important question. In WhatsApp, I send it all of you. Very, number 03, very important question. And I-shaped beam. I-shaped beam is used to carry a uniform distributed load over assembly span L. L equal 24 feet as shown. The maximum shear stress. Asking, where is the maximum shear stress? Where? We already discussed now. The maximum shear stress skips over inch square. In the beam is most rarely select one. Okay. Again, I will repeat it, guys. Our exam is 2 minutes, 13 seconds. What you are expect from these questions? Okay, let us go. I will put the same values. Whatever he have here is equal what here? It'll be equal what? Tell me. It'll be equal? 6 skips, but 6 skips. 6 skips a month, 8 feet, feet. And I have 24. Now it'll be over L. It'll be over L, it'll have 6 multiplied 24 divided 2. Correct? Equal what?
72.
72. What? Stop? No, 72 caps. Don't stop, please. 72 caps. Which formula you are going to use? which formula you are going to use? Anybody remember what is the statical area of any section? LQ. The moment of inertia, you know? I give it to you. Okay. Why, guys? I give you average. Let us apply the average. Let us apply the average. The average is telling you what? Telling you what? Telling you Q 72, V 72 area of the web. What is the area of the web? What is the area of the web?
16 by 2.
يبقى 16 لا استنى show me كده again 16 what 16 inch multiply 0.75 اللي هي 12 inch 12 inch square kips the answer is
হ্যান্ড ওয়াশ করে খেয়ে নাও মা এসে গেছে
نعم
পিৎজা আছে খেয়ে নাও
adjust the camera again
ফিটটা ওয়াশ করে নাও ফুটবল খেলেছো
what again please
sorry yeah I got it sir.
Okay, now 72 kips divided 12 equal 6 inch, 6 kips over inch square, correct?
Yes.
Check your answer.
Yes.
Check your answer. This is average. This is average. This is average. The average here only. Again, here. Here only. This is an average 6. The bottom maximum
6.3.
بس خلاص. Because see the exam, how to deal with your exam. No way, no, all of us, يا أخي, go to your exam كده after even study 100 hours. This equation we forgot. See the trick. The equation is equal what? Shear force over area, but which area? Which area? Which area you are going to take area of the web? See the trick here. We solve this. We solve how many minutes now? 2 minutes, because we calculate it be directly. If you are not practice, how you are going to know that's the reaction directly be L over 2? You will take 10 minutes to solve to get the reaction, and another 10 minutes to think about the question. Another 10 minutes to solve the question. Another 1 hour, finish your exam. But if you know I'm not studying, again, see, trick, yeah, very tricky. Like, how many options we have? We have 4. All of them less than 6. Less than 6. What we calculated is 6. You are for sure 100%. Maximum is 6.3. Logic.
Yes.
Logic. صح. صح. This is the way you are going to deal with your exam. Minimum knowledge. Minimum knowledge. Yes, this is the minimum knowledge.
6.3 progress.
Yes, we calculate the average equal 6. Double maximum.
B divided by area of web.
Right?
B divided by area.
72 over an area of the web. Let 12, let 16 multiply 0.75.
3 by 4 multiplied by 6.
Correct. You already calculated the average, easy or not? Tell me.
He didn't get it.
You don't get it?
No.
Right. Habibi, what is the reaction? Reaction we calculated. B L over 2.
6 into 24 divided by 2.
72, correct?
Yes.
The area of the web عندك, the area of the web, this is the
16 inch length and 3.34 width.
here is what thickness?
16.
0.75 inch. صح? And here is 16.
Area 12.
16 inch. 16 inch multiply 16 multiply 3 over 4
Sure.
equal what? Equal 4 equal here 4 equal 12 inch square. يبقى 72 over 12 inch square equal
6. That is average.
6 kips over what? Don't stop. Over inch square. So check your answer. Number 1, telling you what? Number 1, 2 point something?
2.6.
By this logic, if average is equal 6, يبقى the maximum is 2. طب number B
3.8.
is still less.
Yes.
طب number C
5.1.
5.1 is still less.
Yes.
يبقى for sure 100% is D
6.3.
without calculation. But in our exam بقى, I told you, minimum focus and minimum knowledge to solve out. We cannot study civil engineering in 2 months, in 3 months. You cannot.
So V is the maximum shear, right?
What?
V is the maximum shear, right?
V is maximum shear force,
Yeah.
internal force,
Yes.
maximum internal shear force. Where is always in the support? Means what? In this beam, especially this beam, the maximum shear stress is always in the supports, and always in the neutral axis. Neutral axis. Each section have neutral. All the section have neutral axis, but here the value of the shear is less. But we have maximum shear stresses in the section here, coming in the neutral axis. But the V varied. Okay? Now go for the second one. Before we go for second one, let us see the flexure stresses. Coming where? Coming underneath zero force, shear force point, and maximum moment. The maximum moment equal what? The bending moment stress or the friction stresses. We call it bending moment stress. You can call it like that, or friction equal what? Equal M multiply Y divided I. What does it mean? I will erase this one, okay? I will erase. I am talking about friction stresses and a moment stress, bending moment stress. If you have beam, this beam, it will be bending like that. Coming here. Tension. Means what? At this section. Neutral axis. I'm talking about friction stresses. Some books doing like that. Where is the zero stress in the section? Friction stresses in neutral axis. Zero neutral axis. Friction stresses, I'm talking about moment stress, which is the value of it is equal what? Equal M maximum moment in the middle of the section. Multiply Y, this is Y now. Y, this is Y. Divided the moment of inertia, equal BH square cubic BH cube over 12. Now the formula here. Where is the maximum? In the neutral axis, in the center of the span. Neutral axis is equal 0. In the edges, in the edges of the lower fiber, the lower fiber, and the upper fiber. See, this is the tension, and here is compression. Neutral axis, always zero flexure stresses. In the section, maximum is flexure stresses. Means what here? We have flexure stresses here. Where is the maximum of it? In the edges, bottom and the upper. In this section, we have maximum. Yes, where? In the bottom and the. But the value of M varied because varied. M is varied. M is varied. When we calculate M maximum. We calculate shear maximum. When we calculate the NM maximum in the beam. That's why we study what? We study structure analysis to get all this into design for area of steel reinforcement. Design the BSB is a section. Design whatever the type of structure. I will go for steel structure or concrete structure, convention structure, BDB or hot rolled. With all this economic. When we study the signboard, what I told you, 20 multiply 40 in your top, which system you are going to adopt approach? Which one? Structure, what structure system? Frame or trusses or concrete frame or what? It's depend about that economy. How we are going for a cheaper and a last and as well a rigidity. How much this last for how many years the system? Okay, steel structure or concrete? It depends about stress. Okay. Second question, the answer is A. Don't think about it. The answer is A. Question number 2. The answer is A. Okay. Think about it كده at home. Take one day كده. Sit down in the front of your paper like that. Take one day, think about this question. One day. And honestly, tomorrow is Friday, but the answer is A.
Yes.
The answer is A. Don't waste your time. The answer is A. Copy paste in your exam. Again, repeat it. Blah, 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 blah. A. Without saying, don't confuse yourself. I already explained. I already explained to you many times now. But the answer is A. Class?
Yes.
Don't worry. We are you are in safe hand. Okay?
يعني لما يكون في كلام كتير فيها على طول.
A directly. Two. Just the same. You memorize the question. If this copy paste came to you like that, if this question came to you like that, 6.3, you are going to start. You are going to calculate it again. 6.3, guys. 6.3. What is the tower crane? Question. What's
But
that?
instead of uniform load, if they are using point load, then what would be the answer?
لا don't بقى. If the condition change, different.
No.
If any condition is depend about the external forces, I am just giving you the same, whatever uniform load. If we have concentrated load, calculate the shear, calculate the moment, and the end apply the formula. Simple. Why we are saying if the concentrated load don't? No, it will not come to you concentrated load. But if it will come to you concentrated load, you have the formula. You have the steps, the mechanism. Everything is in your hand now. How you are getting this mechanism? By studying, by solving the homework, by practice. If you are not practice, you are not going to get all this knowledge, guys. You have to dedicate it a particular time tomorrow, especially Thursday. Thursday you are here. You are busy with us. We are busy in the class. You are studying actually. You came here 3 hours is studying. Itself is studying. Tomorrow is Friday. Dedicated 5 hours. What's your problems, guys? Dedicated 5 hours to study. Study. You will gain what? Confidence. This is what we need, confidence. And you are going to go all this knowledge. We forgot all this knowledge. And it's still huge. Don't think we are nothing. We give 30 hours. This is nothing. This is nothing, but I am putting you on right track. Don't think I am having magic stick. No, there is no magic stick. I am just putting you emotionally how to study. Okay? How to study, this is very important now because how many years? We forgot actually. So, we forgot to study. How to say, why you came here? You came here to give injection, yeah, I will give you injection. Don't worry. It will. So now we finish the chapter. Being finished, I will solve number 11 and number 12. Number 11 and number 12. But this chapter closed. I will, inshallah, Sunday. I will bring some papers with me. I am giving a lot of questions in beams, which coming from our previous exams. and we are going to solve it in almost around 30 minutes before starting a project management, okay? So you will have a lot of questions. You have a lot of questions, you have confidence. I need all of you to feel confidence, guys, from project management and from structure. This is a confidence we are. Why? I will tell you why later. Number 11. I told you number 11, he will never give you indeterminate. Indeterminate. And if he will give, he will give you a hint. I told you like that. Where is the hint? Okay, let us see. You have beam. This beam is 3 support, continuous beam with 3 support, hinged support. Hinged support, and tell you what, there's 2 conditions, 2 live load. One of them is uniform. One of them is uniform, covering all the length of the continuous beam, entire span. Correct or not? This is equal 1 feet. Dimension of my beam is 60 feet and 60 feet. Hello. How many support? 3. How many reaction unknown? Please guys, tell me. Unknowns. 6.
Can I get one pen?
Ben? 1 minute, I will bring you Ben. See, we have how many support? We have 1, 2, 3, A, B, and C. How many unknowns? 6 unknowns.
6.
How many equation of equilibrium? Equation EOE equals 3. And now this beam is 3rd degree. Indeterminate 3rd degree. How to solve these questions, how to get this one, and the second condition telling you there is attend keeps moving. Hello, moving. This moving. And I have what?
Excuse me, sir, can you adjust the board?
وبعدين بقى. Okay.
It's okay now. Okay, thank you.
The most one. Okay, now guys. See, we have what here? We have hinge, and the hinge is what? Capital. Telling you what? Arrow كده. Hinge. Hint. Guys, it's 2 minutes, 13 seconds. 2 minutes, 13 seconds. Put your mind, 2 minutes, 13 seconds. Don't think he will give you a questions, need from you half an hour. Logic? Not logic. Not logic. 1 minute, 27 questions in 1 hour. Means what? To read and finish. Read and understand. Sure. This is the way. Okay, طيب how to solve it? Let us see. Hinge. Okay, Happy, I will take the first part. Once he said hinge, خلاص take the hinge. All right, hinge. I get the reaction for. And this question is a ridiculous questions and confuse a lot of engineers. I will consider the life load from B to C. Go in this direction. I'm not happy with you. Consider it from here. Fast. It's moving now. Moving now. I told you exactly where. No, I am moving. Collapse. Consider I move from here to here. What is the problem? What's your problem now? Tell me. Nothing. خلاص.
Let it move.
Let it move. حلو. يبقى now I'm not here. Here. حبيبي, keep yourself here. Move and take your time. Take your time. Moving. Okay. Now I have what? 1K. Over what? This is moving and a covering. يعني covering. خلاص. Consider be a train. Consider be a truck. Consider whatever consider. Okay. طيب يبقى now 1K over feet. And they have what here? 48. صح? This hinge is 48, correct? Yes. 48 feet. يبقى now, what is the equivalent load? The equivalent load is 48 multiply 1 equal 48 kips. طيب, reaction. YA. I can calculate sigma moment at this hinge is equal 0. يبقى YA multiply 48 equal to 48 equal 48 minus plus positive and minus, so it's plus. YA multiply 48 equal 48 multiply 24. From now you have to write this equation. When is the negative, what is the positive? Now simple. Tension in upper fiber negative, tension in lower fiber positive, moment. So fast. How you get fast? Through the exercise. Right, يبقى now 48 يبقى now YA equal 24 kips. Help. I get now a reaction equal 24 kips. Come back to our B. I am happy now to kips. Okay. What is the equivalent load in here from A to B? What is the equivalent load? Is equal 60. Why 60? Because here to here is 60 feet. Now the equivalent is what? 60. صح?
Yes.
Draw the shear force diagram. What is the shear force diagram? Here. Go here.
So why it is?
It is span is 60.
From this span is 60 feet.
to 1.
صح?
Okay.
Multiply 1, يبقى 60. Now, we go our here. Our free body diagram here. Our free body diagram. Here is 60. Here is 24. يبقى 24 up. Okay, يبقى 24 up. 24. 36 down. 36 down. Here. Sorry. What's the value of this value? 10 here. Your 10 here. In the above that, what is the difference? What is the difference? There is the shear force need to cut. The maximum shear force in number 10. You remember? Here's the shear, this is a concentrated load 10. And I have 36. It's still 36. Because the answer is what? The answer is what? You have the answer is what?
36.
36. 36. 36.
Answer is 36.
36. Guys, the answer is 36. Did you understand it? Okay, you don't understand it, the answer is 36. خلاص? Copy paste. Answer is
26.
The answer is 36. Huh? This is the sheer maximum. The 10, what is the reference now? 10 now is telling you down. Did I have any difference? You remember the B, L, and you remember number 10? You remember number 10? What is the maximum shear is equal? B. 36 from this point to this point, correct or not? 36. It's not 46. It's not 46, it's 36. The answer is 36. Remember, number 10 is equal. Number 10 is equal B. Guys, number 10 is equal B. Number 11 is equal 36. Number 9 is A. 7706. Memorize it.
The question is right side of B is most nearly.
بس خلاص here B nearly 36. خلاص بس. Yes.
Why do you keep the moving concentrator node at B?
حبيبي,
It will be maximum
shear, maximum shear.
under concentrator, no?
طب I have concentrated load 10. What I calculate now? 10 here, okay. What I calculate now?
It means more.
No, it's not more. Guys, this 10 down. Already I have 66 up. So what is the problem now?
36 is left side of this section.
Left to right, whatever. Now you have here, you have the section now. You have the section in the B now.
Yes.
Okay. This B have right and left.
Yes.
The section. Okay. I have what I have in the right hand is telling you 36.
Yeah, maximum is there 36.
36. So I will take 36. Why I will consider 10 now? 10 plus 4, 36. No. 10 plus 36 is reaction.
And that will be
Reaction is not shear. Again.
but we take the concentrate to Kepsa. This is the concentrate.
Put it, يا عم, take, put it or not put it. Don't put it at all. Don't put it in your consideration. Forget about it. I told you, let this 10 is moving here.
Yes.
You solve this question by inference line. You need what? You need 10 minutes to solve it. And
Excuse me, sir. Can you repeat one time, sir?
Sorry?
Can you repeat one time, sir? I'm not understood, sir. This.
Okay. Let us, okay, no problem. Structure analysis, as I told you, you need 5 years. You need 5 years, but we are taking only the part from our exam. If we will go for structure analysis, we will not finish. But I am giving you whatever exactly we need. I told you again, minimum knowledge enable us to solve our exam. Telling you here we have how many support? 1, 2, 3. This
Yes.
support have 6 unknowns. 6 unknowns. Okay, but 6 unknowns plus 3 equation of equilibrium. يبقى now this being is indeterminate third degree. But he will tell you, Habibi, Mr. UPDA, there is hinge. What you have from this hinge? Okay, hinge. I will cut here. So you hinge. Okay, cut in the hinge. You cut in the hinge, you calculate the reaction YE, correct or not?
Yes.
Consider a moving load 10 from here, from B to C. Ignore it. Ignore it. What is the problem now? Ignore it. Okay? If the LB here giving you down, giving you down, giving you down, giving you down. Okay, very good, giving down. No, ignore it. Ignore it. This is a ridiculous question, I understand. Very ridiculous. Very stupid. Because if even you don't, all of us, we don't know what he wants exactly. Huh? Anyone can understand what he wants exactly? No, but he will tell me hinge here. This is what I understand. Okay. You got 24. 24 here. I need to check that. I want to put the 60, the equivalent load from this part, from A to B. What is the equivalent load from A to B? It's equal 60. 1 multiply 60 equal 60. Draw the shear force from this point to this point. Only as a bar. As a bar. Take the speed killer as a bar only from the total system. You will draw the beam at 24. Straight here, down, 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 36, and here, 36. Stop. put the load here, the external live load allow 10. What is the difference? It's still 36. It's still 56. It's not 46. Okay? The answer, guys, no need to understand this question. Believe me, no need. I'm telling you, no need to understand. Why? Because it will confuse you a lot. We need to reduce confusion. We need to increase confidence. Okay? Now, if you need to study, Habibi, you have your life, you can take PhD degree in structure. From now, why not? Take PhD. Okay, go study up to, go for online classes and go. But this is our exam. We need like this level only. Okay, don't go beyond. There is 3-moment distribution, 3 influence diagram. You can study, and it will not nice, interesting. Very beautiful subject. You can go online. You can go for YouTube. You can go for books. You can study. The answer is 36. Let us go for number 12. Sorry, guys, online we have no time. Number 12, and still a lot of engineers solve it wrongly. Why? Because we don't know where is the right and where is the left. Where is the right, where is the left? When you are facing the board and you have been like that. This question I will solve it by 2 ways, by 2 methods. See the 2 methods, very simple, but second method is more easy. Let us see. The first method is you have simple supported beam. This simple supported beam is roller support here, and we have hinges here. And this one is uniform load, and